It is my experience that anytime we use the word application or story problem or word problem, or you see a problem that has sentences instead of just straight math, that a lot of students or people in general tend to shy away and freak out. Okay, I've got a couple examples here for vector applications that are going to show you how we take something that can be a little bit scary and turn it into something very simple, essentially using the ideas of your unit circle triangles and some of the formulas for vectors. So the first one is about golf. It says a golf ball is driven into the air at a speed of 75 miles per hour and at an angle of 50 degrees from the horizontal. Express its velocity in vector form. Okay, so what we're doing in this problem is we're kind of tying a little bit of physics here into our trig, but instead of using the normal physics formulas that you would use, we are actually going to use our trig formulas and vectors in order to solve this problem. So first and foremost, we are on a coordinate plane and we are told that your angle is 50 degrees from the horizontal. So that means we're going to be here in this first quadrant. So the first step would be to go ahead and draw yourself your picture. And so here we've got 50 degrees from the horizontal, so I'll go ahead and drop in that vector. That allows me to drop in your vertical as well as the idea of your horizontal here. And what we're told is that this is my angle, which is 50 degrees. We are also told that you're driving your golf ball at a speed of 75 miles per hour. So what that actually means is that this vector form here we would look at in terms of miles per hour. And so this here would be 75 because we're talking about 75 miles per hour. Now here we're going to have your cosine of the angle component, and this over here is going to be your sine of the angle. Very weird ways to label a triangle, but you're going to see why I did it in just a second. What we have to remember here is we have to remember the formula that we're using is your magnitude times the cosine of your angle and the sine of your angle. Okay. Now in this case, my horizontal here I don't have a value for, and I don't have a value for my vertical, but I do have an angle here. So what we're doing is this is going to end up being 75, and then I'm going to have the cosine of 50 and the sine of 50. So why did I label my triangle in this way? Well, it's because it helps you remember what we're doing with this formula. Okay, it's the pieces that we have to use based on the pieces that we've been given. Now in this, we wouldn't just stop. You have to actually do the math here, which means you would evaluate the cosine at 50 and multiply it by 75. It means your component is going to be 75 times the cosine of 50 and 75 times the sine of 50. Now in this case, that's going to give us decimals. So here what we're going to end up with is roughly 48.21 and 57.45. Now that would be the component form of your velocity. Okay, pretty simple. Alright, let's look at another one that has more of a physics twist on it. Here it says Prometheus is slowly pushing a 1,235 pound boulder across a flat plane with a force of 150 pounds. What is the total force being applied to the boulder? So here we are actually going to be in your fourth quadrant, and let me show you why. The first thing that we have is we have the weight of your boulder. So we have this force here that is being applied, down in the downwards direction. And so what that is right here is this is actually the weight of the boulder. Which we were told was 1,235 pounds. So if we actually think about this as being a vector, it would have a component form that would say 0, 1,235. Okay, that is what we're doing here. Now the other piece that we have is we have the actual motion of the vector. And so what we're doing, or Prometheus is doing, is he is pushing that vector along your horizontal here. Okay? And so this right here is actually going to be your force by Prometheus. And when we look at its vector, we're told that he has a force of 150. So this component vector here is going to be 150, 0. So we actually have to look at what does that mean in terms of our vector. Well, we have two vectors that are being applied. They're being applied pulling away from each other, but they both start at the same place. What that actually means is that the vector we have is coming out from the two of them down kind of this way. Okay, so this is actually going to be the vector of your rock, and it is dependent on the force of Prometheus and the weight of the rock. Okay, so if we actually label these, we would say the rate of the rock would be like my first initial force. The force of Prometheus would be my second. So this is actually the vector addition. So this would be F1 plus F2. Okay, that's what we're doing here. So now we have everything we need in order to solve this problem. Okay? And the reason for that is because we have the component forms here of these two forces. So when we have F1 plus F2, what that's saying is that we have 0, 1, 2, 3, 5 plus my F2, which is 150, 0. Oh, I'm so sorry. I sneeze like a chipmunk sometimes. So we have to do our vector addition to add this together. So here, if you remember, it's going to be adding them. So here this is going to be 0 plus 150. And then we're going to have 1235 plus 0. So again, simplify your math and we get 150 and 1235. Okay. Now, that is just the component form of this vector here. We have to find the total force being applied. What that means is that we have to now find the magnitude. So you need to find the total force. You have to calculate the magnitude. So here we have to find, it's essentially the magnitude of F1 plus F2 is what we're doing. So to do that, says I'm going to use its component form. So this is going to be 150 squared plus 1235 squared. And we're going to take the square root. So what you're going to end up getting is we are going to end up getting 1,244.0759, which we can round to being 1,244.08 pounds. So there you go, 2 different examples of some types of application problems that you could use and solve by using the different ideas of vector operations. So if you have any questions, please let me know. Otherwise, I did enjoy it. I hope you enjoyed yourself too, and I look forward to seeing you next time.